Hello and welcome to this lesson about solving systems of equations using substitution. The learning target of the video is knowing how and when to use the substitution method to solve systems of equations. So first of all, let's talk about what the method actually is. And so on this part, we'll talk about the what and the why. And to make an analogy, let's say, I do this a lot when I go get groceries and I use like my debit card or something like that. And I'm like, hey, you know what? I might need some cash. So could you give me a $20 or can you give me 20 bucks back in cash? And sometimes they give me 20, but sometimes they don't have 20. So they're out of $20 bills. And so what they'll do is they substitute it for two $10 bills. And that's kind of what's going on here, is when we have systems of equations, we'll have something like 2x plus 3y is equal to 4, and then we'll have maybe 5x plus 6y is equal to 7. And we want to, we have two variables and two equations, and if we could get rid of one of the variables in one of the equations, it'd be great. And so we're going to substitute one of those variables out for the other one. And so that's sort of the goal here, is instead of getting a $20 bill, we're going to substitute it for two $10 bills. All right? Now, that's the what. That's what the method is. The why, or when perhaps we want to use it, is when things are easy. So use when it is set up for it. For example, let's say we have 2x plus 2y equals 4, and we're told y equals 3x. This system is set up for substitution because you already have this one equation right here that is solved for one variable. And if we wanted to, and we're just kind of hypothetically talking about this, so now let's just say 3x minus 3y is equal to 6, and then we had x is equal to negative 5y. Again, this one is set up to use the method because it's already got x equals. And so all we have to do is plug in this wherever we see an x, or over here, plug this wherever we see a y. So in a situation like this, substitution makes great sense. Now, where it could get a little more complicated, but substitution maybe still is the best method, is something like this. Let's say we have negative 3x plus y is equal to 4. Let's draw a line here so we know this is a different problem. And then we have 5x minus 6y is equal to 30 or something like that. Now here, I would argue substitution is great because we have a variable without a coefficient, or with a coefficient of 1. It's super easy to solve for x or y right here. So I could solve for x or y. In this case, I could solve for y and then plug that into the y down here. So now let's kind of walk through this process. So we talked about sort of the what and the why and the when, but now let's start off with some examples. So for our first example, let's say we have 5x plus y is equal to 15, y equals 2x plus 1. Now, I'm putting this in the category of easy, quote unquote, because, again, this is already solved for y. And so that's the goal, is pick one equation and solve for x or y. Which variable do you want to solve for? The one that's easier to solve for. And so this one, it's already there. So what I'm going to do is now substitute, as the method would imply, this 2x plus 1 where I see y right there. So I have 5x plus 2x plus 1 equals 15. Now I can simplify. So I'll have 7x plus 1 is equal to 15. 7x equals 14. And x equals 2. So I've now found one of my solutions. What I'm going to do is take x, and I need to plug it into either equation. The easiest one would be to plug it into this equation right here, so I can find out what y equals. So y equals 2 times 2 plus 1. So I just put that x, or the 2 in for x, and y now equals 4 plus 1, which is 5. So my solution here is twofold. X equals 2, y equals 5. And I could write it as a point, 2 comma 5, and there it is. And so all I did, though, is substitute this equation, or that part of the equation, in the other equation for y. Now, let's talk about a mediocre example, a medium example. Let's say we had 3x plus 4y equals 12, and then the second equation is x minus 2y equals negative 6. Now, what makes this a quote-unquote medium example is the fact that we don't have y equals or x equals as one of the equations. So we need to make that happen. And so what you have to do is train your eye how to look at this problem, which one maybe is the best one to solve and which variable is the easiest to solve for. And what my eye sees is that that's the equation we want, and I want to solve for x. Because all I have to do is add 2y to both sides, and I get x equals 2y minus 6. Now I have x equals all by itself. And so I can take this and plug it in for x in the other equation. And so now I'll get 3 times 2y minus 6 plus 4y equals 12. And so what this does is it gives us one equation with one variable, and we can now solve that. Now, again, this is a medium example because it requires a lot more work in terms of crunching numbers, distributing, keeping track of all our stuff. And so let's see what we get here. We get 6x minus 18 plus 4y is equal to 12. Combine some like terms, add 18 to both sides. Let's see what we get here. 10y is equal to 30. Y would equal 3. Now again, that's only part of the answer. I have to go back to one of my equations and figure out what the other one is. So if I know that y is equal to 3, I'll go into this equation and figure out what x has to equal. So x equals 2 times 3 minus 6. And so let's see here, x equals, what is that? 6 minus 6? Oh, it's 0. So x equals 0. Our solution here is 0, comma 3. And that's it. All right, so now that was the medium example. Let's look at a hard example. Okay, for the hard one, let's say we have 5x minus 2y equals 10, and 3x plus 3y is equal to 27. Now, what makes this a hard one is that we don't have a coefficient of 1 on any of our x's or y's. And so we need to solve for it. And so what I'm going to do is just pick one on the bottom here. Let's just say solve for y, all right? Because at least 3 plays well with all of those numbers. And I won't have any fractions. Now, if you have an example like this where none of the numbers play well, that means you don't want to do the substitution method, okay? You want to do a different method, and we'll talk about that another time. But for here, what I'm going to do is I'm going to solve for y. So I'll subtract 3x, and I'll have 3y is equal to negative 3x plus 27. Divide by 3, divide by 3. Y equals negative x plus 9. All right, so I had to do some extra work. Now I just take this expression and I will plug it in for y right there. All right, 5x minus 2 times negative x plus 9 equals 10. And again, we can kind of see why again this would be a hard example because I have to distribute some negatives and I got to keep track of everything, make sure I don't mess up. 5x plus 2x minus 18 is equal to 10. All right, continue to simplify. 7x minus 18 equals 10. 7x equals 28. And so x has to equal 4. All right, that's good. Now, take any one of these equations I have. This is the easiest one to use, and plug in 4. Y equals negative, and then in parentheses 4, plus 9. And so y equals 5. And so my solution for this one is 4, 5. And there we go. So there's the substitution method. Let's do a quick recap of everything. So first, for our recap, we want to solve one equation for x or y. It doesn't matter. Then use that equation to substitute, thus the name of the method, substitute, in the other equation. Oops, equation. That's a little sloppy. Oh well. All right. And so that's what it boils down to. Then just make sure that you are careful and you get an x equals and y equals for your answer. So sometimes students forget to do the x equals y equals and they get one answer, they think they're done, but you need to have both an x and a y. So good luck with your homework or practice, and let me know if you have any questions.